Okay, let's talk about strings. A string is a sequence of Unicode characters. So you could say, so let's say this is how you can declare strings in C sharp. You can say name equals Jupiter. And in C sharp, string is an object of the System.String. Let's do it like this. Um, System.String class. Okay? Which means that we can also declare a string objects like this. System.String name equals Jupiter. Now, the only reason there's uh, an error here is because we have already named an the variable. So if we go ahead and do this, then it should work. Shouldn't Then it should compile properly. All right, so we can say .NET run, and it'll say Jupiter. And if we comment this out and use the one with just the string, it should work as well. Same way. Okay, so gives us the same result. So this is just a shorthand of saying System.String name. This is the same as this. Anyways, and of course you can declare it using an implicitly typed variable. So that would just mean var name Jupiter. And if we do this, and if you hover over this, it would say local variable string. It will interpret as the compiler will correctly assume it's a string. So if you're coming from, let's dive deeper into strings. If you're coming from the low level programming language C, which the most important programming language, at least in my opinion, and you'd find a lot of people would agree with me. Strings are declared using an array of characters or char, something like this. This is how you would declare strings in okay. When you declare it this way, again in the language C, this is not going to work because you can see a bunch of errors because this is not valid in C sharp. But in C, the null terminator is automatically added like this, which is when you put backslash 0. Sorry, yeah, that's the null terminator. Okay, at the end of the object. Or you could, in fact, you could specify the size if you wanted, which gives you extra space for future modification. You probably shouldn't do this. Well, that's a I don't want to get into C. But the point is, this is in fact what is happening under the hood in C sharp. But because it is a high level programming language, we don't have to do all that. It's all abstracted away for us. So we can just say that it's all abstracted away from us. So another way we can declare strings in C sharp is that String is a sequential collection of System.char objects. And here, let me show you something cool. Let me show you something very cool. Okay, let's call it alphabets. Ju Jupiter. Okay. Okay, let's say Jupiter like this. We've just named a bunch of a character array of, a character array called alphabet with all this Jupiter. And let's say, and so now we can say, and check this out, name. You know what, let's call it name like this. We can say new string, and we'll say alphabets. And check this out, there are no errors. This is a valid way to declare strings in C#. You can see the compiler doesn't give us any errors. Obviously, we don't do this. Too much hassle. We just do it the first way, which is, of course, the way I say. Sorry. Name. Jupiter, like this. But this is actually valid, and my point is, it gives you a clearer picture of what's going on under the hood. And you know what? Let's go ahead and run it so you don't think. And you see, Jupiter. It works perfectly. Let's go ahead and clear this up. And yes, you can declare numbers as strings too. When I defined strings as a sequence of Unicode characters, Unicode includes Arabic numerals and even symbols like currency, like currency, question mark, period, and things like that. Greek alphabet, alpha, beta, sigma, all that. Look, I know this video seems slow going, but that's the point of a deep dive series. It's really important to understand how code works under the hood, not just how to declare strings, but what are strings. So, let's talk about properties and characteristics of strings. Anyways, unlike other C# built-in types like bool, let's say is valid, you say true, byte, small number equals 10, char, symbol equals $, int whole number equals 544. This is just random. Or decimal fractions equal 4.660, which is, these are all things that, wait, decimal, there we go. These are all things that we covered when we talked about primitive types previously. Unlike this primitive types over here, strings and arrays are different from these primitive types for a few reasons. First, they are made up of smaller pieces. So things like string, well, let's put back the name Jupiter and and arrays. It just puts um, stuff. I don't want to overthink things. So um, both of them are different. Strings and array are different from primitive types because they are made up of smaller pieces, which means they are more complex. You know, string is made up of, these are all smaller pieces that come together to make up a string object, and these are all smaller pieces that come together to make up an array. So, anyway, when you create, so which means they're more complex, and complex data types are almost always stored in the heap. Okay, so I already talked about heaps and arrays. So it's like this. It's stored in the heap. The value is stored in the heap with a reference that points to the reference that points to the heap stored on the stack. Basically, this points to this, and the real value, the real data, is held on the heap. Okay. The variable in the stack holds a reference or called memory address that points to the string on the heap. Primitive types um, are value types. So if this was an int, for example, it would have the value, and I say 45, it will have the value right there on the stack. Okay. Now, I don't want to get too deep into memory management. Not yet. At least not on a C# video, anyways. Maybe in the future when we talk about C. But if you're new to software and you've heard phrases like pointers, reference types, value types, well, that's basically what I've just explained. But not deep enough. So the first um, the first property the first property of strings is that strings are a reference type, which means they are stored on the heap. Okay? Secondly, and this is the last time I will bring up arrays, forgive me, we can access each character in both arrays and strings. So let's say um, array word. Let's demonstrate this. WX Y Z. Anyway, and we say let's call this string word. Okay, and let's call it A B C D. So these are 1 2 3 4 4 characters, 4 characters for both of them. Okay, let's actually change this to let's do it this way. Okay, and let's see if we can access each character in both arrays. Let's try to get the last character. So we'll try to get the last, which is D, from the string word, and the last character, which is Z, from the array word. And we can say $, say string word string word, and we say, so this is, in computer science, everything starts at an index of 0. So we say 0, 1, 2, 3. We say 3, not 3, not 4. And then let's do the same with array word. And so 0, 1, 2, 3. Let's see if it works. Let's see how good. Let's see if we can get both the letter D and the letter Z. If everything works right, then that's what we should get. Okay, it worked perfectly, D and Z. Now, let's try to change the first character and display them in the console. The very first character. Let's start with, you know what, let's start with the array. The very first character. So we say, let's delete this line. And we say array word 0. Let's change it to the letter A. Okay? And we say let's remove. Let's see if we can change the first letter from this W, capital W, to a small a. And we see, let's go ahead and clear the screen. .NET run, and we see that it says, okay, it worked perfectly. Small letter A, X, Y, Z, because we changed this to this. Now, great work. Worked just fine. You can see that, everything works perfectly. Now let's try the same for our string. Okay, so rather than array word, we just say string word. Let's change the first character from A to a, to a Y, small letter Y. Okay, and straight away we see a massive error. It says property or indexer string this int cannot be assigned to dash dash. It is read only. So what's happening here? Let's try this. I don't even think we can compile it. All right. Error. Property or indexer this cannot be assigned. It is read only. What does that mean? Well, strings in C#, and I'm not sure, but I think most, if not all high-level programming languages are actually immutable, which is just a fancy way of saying read-only. Once you create a string, you cannot change it. Well, technically, you might. You might. Technically, you might modify the value. Let's say, let's get rid of this. We're no longer talking about arrays. But let's say string word XY ABCD. We can now say string word equals EFGH. And so let's change this to string word. And if we compile this, let's clear this screen. .NET run, we see that it says EFGH. You see, we declared it ABCD and then changed it to EFGH. Let me be clear. What you've done is you've created a new string object and changed where the reference pointer points to. Here, I think I have a diagram for this. Okay, so this is, rather than name, let's change this to string word. Okay, this is it. When you put this original, ABCD, okay, when you change it to EFGH, you don't actually override this. What you've done is you've created a completely new object with EFGH. Okay, it leaves. We'll go ahead and delete this. It leaves this, and it changes the memory address here, and it says 77, which now points to this. That's what you've really done. The object you created, this one, the first ABC, is still there. So what happens to the old string? Well, C# is a high-level programming language, and like all high-level programming language, it has a garbage collector. Eventually, the garbage collector will run and free up all the memory allocated to this string. Okay, which means that the garbage collector behind the scene in the program will come when there's nothing referencing this. It's not being executed. It will delete it. Okay, and there we go. The second part of string. So if you modify this any further, it will create a new string and create a new string and create a new string, and it will change the reference on the stack to point to the newer one and the newer one. And so that's the second property of strings in C#, is that strings are immutable, aka read-only. Immutable, read-only. Once created, they cannot be changed. Now, the third property of strings is the length property. The length property of a string gives the number of characters in a string. So let's say string vegetable. I say cucumber. You say int. Let's go ahead and it's okay. You say int number of characters, and we say vegetable dot length, and we can say number of characters. And now we can run this. We can find out how many characters are in the word cucumber. And we say .NET run, and it tells us 8. And there are in fact 1, 2, 3, 4, 5, 6, 7, 8. 8 characters in the word cucumber. Anyways, what if we wanted to get the last character? The last character of cucumber. That's the letter, of course, R. Well, let's find out. We can say we'll change this to a char because we're getting just one character. Last char equals vegetable dots. Actually, we put it in an array and get the vegetable dot length. Okay, and we say, of course, we've deleted number of characters, and so we call it good lord. We say last character. All right, let's see. .NET run, and it says, okay, so we have an error here. It says unhandled exception. System.index out of bounds no, system.index out of range exception. Index was outside the bound of the array. That should be okay. Of the array. Okay. Who can tell me based on this exception? Can you guess what the problem is? Remember something I said earlier. The reason we're getting this error is that there is no character at the index position of 8. Remember, there are 8 characters here. Strings like arrays are 0-based indexed. So we start, remember when I said that? 0, 1, 2. When you count, you actually start from 0, 1, 2, 3, 4, 5, 6, 7. So the indexes are 0 to 7. So to get the character, so there are 8 characters, but when you count in computer science, you start from 0. So technically 0 to 7. To get the last character, we have to subtract 1 from the length of vegetable. So we just put in here -1. That's it. Now let's try running that again. And we say, let's clear our screen. Let's see if it works now. .NET run, and it says R. We got it. We got it. Perfect. Okay. So let's talk about important C# methods. Okay, we've talked about the properties of C# strings. We've talked about the, well, you're right. The last property we didn't write up. I knew that I left out something. Is the string has a length property where we use to find the length of a string object, which means the number of characters. Okay, now let's talk about important string C# methods. Okay, string objects, like all objects in C# come with several methods. There are many, so I'll divide them into 4 categories. Let's start with editing. Yeah, and I think I wrote them out. There we go. Let's start with editing. This one right here, editing methods. We have string.replace. Okay, there's gonna be a lot of them. String.replace is exactly what it sounds like. String.replace replaces all occurrences of a specific substring with another substring. So let's say string text equals hello world. Okay, and so we say string new text equals text dot replace world with C#. Wow. So let's remove this and write new text, and we can see, let's hope this works. We say .NET run, and we go hello C#. You see, hello world. We replace the word world with C#, and now we get hello C#. We replace this with this, and that's it. It's that simple. Okay. Next up we have what do we have next? Oh, okay. C# string.remove. And so let's go ahead and do this, and it says, well, and string.remove is exactly what it sounds like. It removes a specified number of characters from a string starting at a given index. Okay, so you have hello world, and we can say string results equals text dot remove, and we can say, okay, so this is 0, 1, 2, 3, 4, 5. By the way, the space is also a character. Okay, so starting at index 5, remove 6 characters. So this is at this index, we say 1, 2, 3, 4, 5. Okay, so we're going to remove, starting at index 5, remove 6 characters. This is 5 plus the space is 0. So we can say starting at 5, remove 6 characters. Okay, and we say results. Let's see if we can remove the word world, and we say .NET run hello, and that's it. We removed world and just left the hello. And so that's what string.remove does. Next up is, what do we have next? String.insert. String.insert is exactly what it sounds like. When we insert, it inserts a substring into the new string at a specified index. So we're not gonna change any of this. We say, because we need to speed this up, we say insert at 6, starting from 6, we say, let's put the word beautiful. Okay, so let's see. When we hit this point, we should put hello beautiful world, and let's see if it works out for us. .NET run, and it says hello beautiful world. But as you can see, the beautiful and world are together. That's because, like I said, even space is an actual character. So let's go ahead and put space here. Save, and we try it again, and let's see if it works this time. Hello beautiful world. Hello world, but we added the word beautiful after counting to 0, 1, 2, 0, 1, 2, 3, 4, 5, 6. Then we added the word beautiful. And so it works. And then after beautiful, we added an extra space, and it works perfectly. And so let's move to the next one. String.toUpper, and it's exactly what it sounds like. It converts all characters to the word it converts all characters in the string to uppercase. So we can just say text.toUpper. It's a method. So, and the hello world should say .NET run hello world all uppercase. And next up, it has to be to lower, right? Okay, to lower. And so, so here, let's start with hello world, and to lower, .NET run, and here we go. It works perfect. Remove from hello world from uppercase to lower. All right. Now we're done with editing method. Replace, remove, insert, to upper, to lower. Next up, let's talk about C# formatting methods. And we have string.concat. which of course means concatenation. Let's talk about concatenation in general, anyways. You say so strings can use some operators like plus, the way a math operation would use, but rather than adding letters, which of course doesn't make any sense, it would instead join strings together. So we say greetings, we say hello, and we use the plus symbol and say everyone. And let's see if that works. Greetings. .NET Run, and it says hello everyone. And once again, it's joined because we didn't add any extra space. But so let's go ahead and do that. So we say hello plus an extra space, then another plus everyone. Let's see if it works now. Let's see if it works the way that we want it to. .NET Run, and it says hello everyone. You see that extra space that we added here? So this is obviously a mess, okay? But the good news is we have the string.concat method. This method right here. So let's use it to fix this mess. Let's not delete it yet. Let's just say string greetings, and instead we say equals string dot concat hello. Remember we need to add an extra space, and it says everyone. And let's see if it gives us the exact same result. It should be identical to this, and it says hello everyone, exactly the same as this. Okay, so this is obviously a much cleaner way than this. Now, for a more practical use of strings when formatting, we have the string.format method, and it says the string.format method, it says let's say name Alice, int age is let's say Alice is 40 years old, and string message, let's put more space in this, and we say message, we'll say string dot format zero, okay, is 1, okay, years old, full stop, comma, name and age. Okay, so we put the format method here, and then we put in the forgotten the word is, it's oh, there we go, arguments. Arguments, we put in the argument here, which is name, and so let's see if it tells us that Alice is in fact MSG clear .NET run. You see, and it says Alice is 40 years old. when it hits this point, it goes to the very first one and the very second one. So it starts at 0, 1. It takes in the arguments. That's what I was gonna say. Argument arguments. Alright. But in 2015, the .NET team added string interpolation in C Sharp 6. Wow, I can't believe it's been 10 years. String interpolation provides a more readable and even more convenient syntax that is flexible to form strings with just the $ symbol. So rather than doing all of this, and again, I'm just gonna comment this out. But rather than doing all of this, I'll just say message, and rather than all these formats and all that stuff, we'll just say, just put the $ here, and we say name is age, years old, and we don't need to put in the arguments. We can just do it like this, making it much cleaner and much more flexible. And let's see if this works perfectly. Alice is 40 years old. Perfect, isn't it? Okay, so next up we have string.substring method. Substring extracts a portion of the string from a specified index. Okay, so let's go ahead and say, we're done with this. Let's say string. Let's go back to our first hello world, and we say substring, the very first substring sub, and it says text dot substring world from the index of 6. It says this is 0, 1, 2, 3, 4, 5, 6. Okay, if we just put in 1 there, it would just say, when we say substring 6, when you get to 6, we're saying to copy everything after 6, starting from 6 right here. And if we run this, we should get the word world. We've extracted a portion of the string from a specified index, and we see 6. We 0, 1, 2, 3, 4, 5, 6. Starting from 6, we copied the word world. Also, we can be much more specific. So we can say, starting from, we can do a starting index and then where we want to end. Okay, so we can say from 0, this is 0, all the way to, this is 0, 1, 2, 3, 4, 5. To end at 5. So we can extract the word hello.net run, and we extracted just the word hello. So it goes both ways. You can say extract everything after starting from a certain index, or say from this index to this index. That's all I want. Next up, we have string.split. This. Okay, and it's exactly what it sounds like. It splits the string into an array based on a delimiter. Okay, so let's use fruits. Apple, comma, banana, BANANA. Okay, and orange. So now we can say, let's say we want to split all these strings based on this comma right here. We can say um, which means we'll be getting a bunch of different words. So our return type will be, geez, will be an array of strings called fruits, text dot split. Then we get to add our delimiter, and our delimiter is of course a comma. So every time you encounter a comma, that's a new word. That's just what it means. And so we say for each variable fruit, let's just call it f in fruits. Okay, we say console dot right line. Uh, let's put the fruits. Let's delete this. All right, so clear, and it says .NET run. Hopefully, this will give us all new separate words. Okay, Apple. When we get to the delimiter here, this comma, apple, banana, orange, apple, banana, apple, comma, banana, comma, orange, comma. So these are three different words. We've broken up this long string into three different strings. And that's basically what it is. And also, it's not just this. We can do it with, let's say, space, for example. And we get rid of this and just put space like this. And it'll work. Okay? .NET run. So the delimiter could be, and we have the same result. The delimiter could be a symbol or just space or actual characters. Anyways, let's keep going. And we have string.trim. String.trim. Trim is used to remove leading and trailing white spaces. Once again, white spaces, as I've said a couple of times now, is actually considered a character. So, let's say text. Let's give space and say 3 spaces and say something, someone, and give a couple of spaces and then say this. Now, obviously, we're gonna remove this. Okay? If we were to write this down, we could see. Let's actually bring this closer. Let's clear this up and we say .NET run. Okay, we can see a trailing space here, and actually here there's also trailing space. All right. When we say, if we want to get rid of all the trailing beginning and leading and trailing white spaces, we say string trimmed. Let's give this space so it's more readable. String trimmed, and we say text dot trim. Right? Rather than returning text, we're returning trimmed. Let's see if that works out for us. .NET run, and here the space, they're all gone. We've removed the trailing and this space right here and this space right here. That's what we've done. Okay. Let's talk about toString. I didn't put it here, but okay, yeah, I did. toString. Okay. toString is ToString, remember close to the beginning of this video when I said you can represent numbers and even symbols as strings? Well, the ToString method is used to convert objects of a different type to its string representation. So I could say variable number called 1, 2, 3. Okay, and if I do this, for example, number dot get type. Let's see the type. .NET run, and we can see that it is system.int32, which is an integer. Okay. Now let's convert this number to a string and say num to string, and we take this number dot to string. Let's see if we've converted this number to let's see. .NET run. .NET run, and we see system.string. Okay, because we said ToString. So this method is one of the most widely used string methods in C#. A lot of JSON conversions, for example, we use JSON. When I say JSON, what I really mean is JSON, like this. One of the most popular and most important things used. I don't want to deviate too much, but converting from strings to JSON or JSON to anyways. So ToString is one of the most important methods in all of C#. Now let's talk about. So we're done with editing method, formatting methods. Now let's talk about search. C# searching methods, and we say, oops. The first is string.indexOf. And what .indexOf is, it returns the first index of a specified substring. So let's go back to our hello world. String text equals hello world, and we say index int index equals text dot index of world. Okay. .NET run, and we see it's 6. So what we're trying to find the index of the word world. So it says 0, 1, 2, 3, 4, 5. The space is again an actual character, and world starts at 6, and it's perfect. If the index is not found, it'll return a -1. Let's actually try that. Let's say Zeus. let's see, just for fun. We'll get back. Oh, there we go, -1. I was right. Okay, next we have the string.last index of. So once again, if the last index just says returns the last index of a specified substring. Okay, and so let's say hello world. Let's do it, and we say last index of world. There's two worlds now, so let's go ahead and see. Last, and we put here last. Let's see if we, you know what, let's actually see, let's try to get the answer without running this. So it's like 0 1 2 3 4 5 6 7 8 9 10 11. All right, the last world should start at 12 if we're right. All right, .NET run, it should say 12, and it does say 12. This starts at the index of 12, the last index. That's why I put two worlds, so we're counting from the last world. Okay, once again, you'll get a -1 if it wasn't found, so if we put it in Zeus again. Next up, let's talk about string.contains. Well, it's this is a searching function. So it says contains is probably the string method you'll use the most when trying to search. Contains checks if the string contains a specified substring. It returns true or false, so it's Boolean in nature. Let's demonstrate that. So let's say Julia is my friend. Okay. Bool contains, so text dot contains the word Julia. Let's see. And because we know the word Julia exists, it should say yes. True. It should return true. And it does. Now, what if we changed it to James? Okay. Clear. And I see .NET run. It says false. There is no James in here. So the next one is, what do we have next? Okay, so we've done contains. Okay, starts with. Starts with is it's what it sounds like. It checks if the string starts with a specified substring, and just like contains, it also returns a Boolean true or false. So we say James is a cool dude, and we say bool starts text dot starts with James. Okay, this should it does start with James. This should return true. .NET run, and it says true. Perfect. And if it says, let's change this to dude. Does it start with dude? No, it ends with dude. So if we run this, it's going to throw a false. False. It doesn't start with dude. Now, we have the opposite, of course. You already know where this is going, which is ends with. Ends with James is a cool dude. We can do end and say text with ends with. And if it does it end with dude, the answer is yes. But let's go ahead and do what we do best. And so .NET run, and it says true. It ends with dude. And if we say, does it end with James? No, it doesn't. It starts with James. So we should get a false. False. Correct. 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 All right. I don't understand. This is, of course, not supposed to be here. It's in string formatting. So we have covered C# editing methods, formatting methods, and searching methods. Next up, string comparison methods. So let's talk about let's just talk about the equality operator. Okay. Well, our final category of string methods involves comparing strings. We start with the equality operators like equal, equal, and not equal, things like that. Just like we were able to concatenate strings together using the plus operator, we can compare strings using the equality operator. So we say string str1 equals friend, string str2 equals friend. Now we say bool results equals str1 equals str2. It will return true if both of these are equal to each other. And we say .NET run, and it says true. True. Because these are exactly the same. Both start with a capital letter, which equality operators are not really well. Before we do that, let's go with let's talk about not. Let's check if they're not the same, and it should give us false. Sorry. .NET run, and it should say false. It says false. It says bool results are not equal. Well, that's false. They are equal. And while we're at it, equality operators are not really favorable though, because they are case sensitive. You see, so let me put it to you this way, okay? Okay, so let's say this was small letter. Even though it's the same spelling, it's actually going to give us false. False. And the reason is because equality operators are case sensitive. So even though this is both friend, one is small letter. You see? And that's where we get the with the equal methods. String.equal. String.equals. Okay? So we can say with the equal method, the default is still case sensitive though. So just, oh god, I shouldn't have deleted all that. Maybe just this. Okay, we'll call this case sensitive. But rather than doing this, we're not gonna do str1 dot equals str2. Okay, let's say case sensitive, and it's still going to give us false. No. So why are we still using it? Well, we can make it case insensitive. So for example, we can say str1 equals comma, okay, comma, string comparison dot ordinal. So we're now going to ignore the case sensitivity, and it's going to give us .NET run, and it's going to say ignore case sensitivity. Oh, sorry. Ordinal ignore case. Okay? Sorry about it. Let's try that again. .NET run, and it should say true. What we've done here is we've ignored the case sensitivity. Now we get true because, case ordinal ignore case instructs the equal methods to ignore the case sensitivity. Without the string comparison overload, it is case sensitive by default, as you've already seen. But you can make it explicit by, I don't know why you would, if you leave it just like this. But it's better, I don't know the difference. Next up, I don't know why you would do this. Because if you remove this, then it is case sensitive anyways. So that might be overkill to just put the ordinal there. Only if you want to make it case insensitive, then you say, ordinal ignore case. Next up, let's talk about the final one, string dot compare. Okay? This is the last method today, as you can see. This method returns an integer indicating the lexical relationship between the strings. To put it simple as possible, we say Joe, okay, Michelson, all right. So we can say int result equals string dot compare str1 str2, and we say result. Okay, so it will return a negative number if str1 is less than str2. Let's actually write this down. Zero negative number if str1 is less than str2. Okay, it will return 0 if str1 equals str2, and it will return positive number which is greater than 0 if str1 is greater than str2. Alright, so let's Let's clear this and test out our theory. And we have -1 because str1 is less than str2. We can see str1 is only 3 symbols. But let's say let's switch it up. Okay? This is the best way to compare. And we say .NET run. Okay, 1 greater than 0 if str1 is greater than str2, and we can see str1 is greater than str2. But let's say they were both the same. They were both the same numbers. Then we would get .NET run, and we should get 0, which means that they are the same. So that's all there is. Before we leave, of course. In conclusion, let's talk about some best practices to keep in mind when working with strings, which it's all the time, especially if you're making an actual app and handling people's data. If you want to create and initialize an empty string, you might be tempted to do this: string new string equals like this. Don't do that, okay? Or perhaps this: string new string 2 equals null. Okay. I suppose this will not throw an error immediately, but you could run into major issues when building a real world application. Okay. The right way to do it. You know what? Let me go ahead and put wrong. In older codes, you will see something like this. The right way to do it is to say string new string 3 equals string dot empty. This is the best way to do it. Okay? It won't blow up your application during runtime. Also, it's much clearer. This is also much clearer. Let's talk about in our next best practice is about comparing string comparison, which is if you want to compare different strings, you say if str1 equals str2. Let's just go ahead and string str1 something. I'm just trying to make a point here, but someone. Okay? You might be saying, this is the wrong way. If str1 equals str2, you say return 0 or something. Okay? That's the wrong way to do it. Okay? The right way to or you can say str1 dot to upper equal str2 dot to upper. Okay, in order to then return something else, return 2. Okay, the right way to do it is to say if string dot equals, okay, str1 str2 string comparison ordinal case. Then you can say return 3 or whatever it is. This is the right way to compare two strings. Okay? And next up is string concatenation. When combining strings, rather than using something like first name John, last name okay, you might be tempted to say string full name equals first name plus last name, and then don't do that, and then you put full name here. Okay, the right way to do it, as we've already talked about string interpolation, is to do this $, first name, you put curly braces, you wrap your arguments in them, remove this plus. First name, last name. This is much better. Okay? So, checking for empty strings. When working with people's, let's talk about, checking for empty string. When working with people's data, it is always important to make sure users' input is always in a valid state. Sometimes there is no room for mistakes. Like if people are paying you for something, so when money is being exchanged, it's important to keep things as clear and correct as possible. So how do you check for empty strings that are actually required? You could say if username equal empty, then you say then you want to return error or something, right? You might be tempted to do this, or you say return null, and this is similar to these. Both ways are wrong. Instead, what you need to do is if string dot is null or empty, user name, okay, then you can return whatever error that you're trying to fix. Now let's talk about culture variants. Culture aware operations. Okay, when working on an app used by people from different countries and continents entirely, remember to keep in mind that their writing and reading might be different. Always apply culture valid operations. So if you want to say it to upper, you say string upper inputs. All right, let's go ahead and just create string inputs Daniel or whatever. So now we say inputs dot to upper. Okay, technically there's nothing wrong with this, but your app isn't going to be used entirely by people writing and reading in English. Okay, so even though this is not completely bad, but it's still the wrong way to build an application. Okay, the right way to do it is to say uh, string upper one is to say inputs dots to upper invariants. Okay, that way you can account for different languages and different cultures. Okay, um, we've already talked about that when comparing as well. String comparison, that's culture, current culture, and things like that. Finally, memory efficiency. Well, not finally. Remember earlier when I said that when I was talking about properties of string, the most notable property of string is that strings are immutable, read only. Once you create a string, you cannot change it. When you perform any operation that appears to modify the string value, you're actually creating a new set of strings. So, so let's talk about just memory efficiency alone. We say gubernatorial. I say console dot write line. I say word. Okay. .NET run, and we see that is going to say gubernatorial right here. Okay. Now, if we say word equals presidential. Okay, now it says, as expected, presidential. Okay, you didn't change the word, you created a new one. And the reference on the memory address, which is stored on the stack, I think I already talked about this. But it's important to actually remember, what we've done here is we've created a new one. And now it points to a new one. And when you change it again, it points to a new one. And a new one. And a new one. All those things you're creating over and over and over and over again. And this applies to everything. Remember, once created, cannot be changed. All operations like, okay, let's say string str1 Avery str1 dot equals str1 dot to upper. Now we're going to say it's going to give us Avery. Okay, we say str1 equals str1 to lower. We just said Avery. Okay, we say str1 equals string dot concat str1 Avery James. Actually, Avery James. Okay, let's go ahead and see. Not that. Clear. .NET run. Okay, Avery James. Okay. Okay, we have changed this multiple times. Each time we do this, each time when we created just to change it to upper, we have to create a whole new one. To lower, a whole new object, string object. Concat, a whole new string object. Okay, every single one of these operations methods actually created a new string object, all four of them. The first three objects will eventually be deleted by the garbage collector. Okay, the first three will eventually be deleted. But the garbage collector running multiple times is very tasking. Just imagine millions of people doing this on a real app. There are two useful ways to mitigate this problem. First is the string builder. There's a string builder object. String builder. Oh, let's not do that right now. String builder object. So here, let's put out a bad example. Okay, so let's say let's create a for loop. Int I classic equals 1. We say I is less than or equal to 100. I good lord, plus plus. Okay, and we say output plus equal I plus, let's create a new line, console.write line I. Okay, and we say thread dot sleep. Okay, 500, which is half a second. 1000 is a second. Let's delete this. Okay, let's go ahead and print the accumulated string. Hold on to your horses. Actually, let's clear .NET run. And we can see 2, 8, 10, 12, 13. And we're printing the accumulated string. Okay? Every time we create a new one is created, a new one is created, a new one is created. So the garbage collector will have to run 99 times. Let's go ahead and just click. Let's cancel that. 99 times. This is bad. Okay, let's use a string builder. There's an object. There's a string builder that we can use to make this better. And we say string builder. Okay, and we need to bring in string builder. Let's call it SB. New string builder. Let's go ahead and just delete this. Okay. We'll leave this the way it is, but we'll say sb dot append line I dot to string. So now we're appending strings. Okay, console.write, console.sleep. You know what? Let's make it that way. So this is a much more effective way of dealing with it. We're adding more and more strings as we go along. But what we're doing is we're overriding the original string objects. Okay? What 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 string builder does, let's cancel that. What string builder does is it, when you use a regular string, okay, and you create a new object, as we've already demonstrated, it creates a whole new object and points to it, and then a whole new object. Obviously, this memory changes, but you get the idea. Whole new object. What string builder does is that it points directly to that object in here and modifies it, making it much more efficient, so you don't have hundreds of objects all the way. All right. And that's it. That's what we're going to talk about today. Thank you for watching this video. If you enjoyed my deep dive series, please like and subscribe to the channel, and leave me a comment on what you think, how I can improve my videos, or just let me know, even if you think I suck. Thank you.